Welcome back. We are COMP1115. That's Game Programming 1 in the fall 2025 semester at Georgian, and it's week 3, part 2 of our broadcast and recording together. And coffee is a good thing, right? But now, what we're doing is, in this one, Nectar of the Gods. Okay, let's continue. We're going to go to here. And this is where we were left off last. So you should be here at this point right now. But we're still got a problem. We've done this. One thing you haven't done, some of you, is included me as a collaborator in your GitHub repo, because I only got a few people that invited me, right? So let's not forget that. Let's go back into GitHub. And remember how to do this. You go into your repository, into your settings, and on the left, there's collaborators and teams. Damien, you did this already, so you don't have to do it, right? And then you sign in. Right? And you'd sign in with your two-factor authentication, like we always must do. I think this day and age, if you don't have a two-factor and you're trying to do something, you know, you just risk all kinds of bad things. So please, especially in things like your, beautiful things that we have on Steam. If you don't have Steam Guard, somehow, weird. Right, you should have it now. Some people can. I know lots of people that have been bamboozled and lost their Steam accounts and all kinds of great stuff. Discord, right? I mean, two-factor should be part of your life, right? So anyway, so now that we've done this, we're in here. Remember, what we want to do is add people, and you want to add me. So the way to add me is just put in my first few letters of my last name, like first several letters, Ciliop. You can find me at my first name, last name. That's it. That's the guy. And once you include me, then I will get an invite. Now, here's something about invites that I had a bunch of you guys have incorrect repos. If you give me an invite for this repository, okay, I just want to put it out there to you, okay? And then you create another repository because you messed up, and you don't invite me to that one. And then you give me the link to the wrong repositories, which is maybe what happened to some of you. Right? Then you're like, yeah, but I invited you. Yeah, but you created two repositories. And yeah, you didn't give me the one that I was supposed to get. So please make sure that your link that you put up on Blackboard is the link to your repository that you invited me on. Okay? Oh, come on, by now you should have it memorized. You think? Oh, there you go. Okay, here it is. T-S-I-L-I-O-P. Okay? Try it. Let's see. I test you. When I was young, okay, people called me Tommy Alphabet. They made bad things happen. They said silly octopus, okay, but that's not my name, all right? It's not that, all right? But it is close to the beginning. So it's T and S together. I feel like I'm Chinese. Right? And then it's Ciliopoulos, and it kind of flows. Ciliopoulos, right? That's the way you say it. Absolutely, my friend. Emailing us. All right? That's it. Let's move on. Now that we've got that and we've added new stuff, we talked about this at the break. Before the break, we said, hey, we've got this if statement, and the if statement tests a condition, and then if it passes, it executes all the lines of code inside the curly braces, and if it fails, it skips everything. Okay? I can do multiple conditions like this. Okay? Like I can do multiple if statements. Let's do it again. Let's try something else. Let's say if. And I say character name, and let's say is equal to, let's try another name, like Bob. Okay, you decide the name you want, okay? And we can say simply console.writeLine, welcome Bob. Well, maybe if I can spell writeLine properly in my adult age. All right, there we go. So I got two if statements. These are two different branches of logic. I can pass or fail this one, and I can pass or fail this one. But I want to tell you something, guys. Both of these will be tested. Both of these will be tested, okay, in this case, right? Because there's two separate statements. These are separate, okay? So if I press play and I run this thing, then if I test either Tom or Bob as the name. So if I put in Tom here, we're good, right? And if I put in Bob there, or you can put whatever you like, Bob, right? Bob is good, right? But if I put in some other name, right, like Sarah, we're not good. Okay, that doesn't show anything. Why? Sarah didn't pass the test is the answer, right? Tom and Bob both had different tests, 2 different tests here, and they both passed when I typed them in, okay? But this, my friends, is very inefficient. I don't want to do if and then another if and another if and another. I could do ifs for all kinds of names. Imagine if I had ifs for like, I don't know, 100 names. Wow, that's a lot of ifs, right? So that's not good, right? Where it's more common is where I'm testing for certain things, right? But I could do something called an else if. Try this. If I just put an else in front of the if like this, now these 2 statements are one big statement. Okay? One big statement. If, else if does this. It looks for the first case. This is the first case. Character name is equal to Tom. If it fails, it'll test the second case immediately. If that fails, it will do nothing. Okay? And there's one more thing you should know. We could also put in a default case, which is else by itself, with just nothing else, just else like this. If I just do else, right, notice there's no brackets here or whatever, because we can put in console.writeLine, and we can say, you know, some other name was entered, right? Because if it doesn't pass, if it's not Tom or Bob, then it's something else, right? And that's what the else statement does. So let me go through this. So this is the first condition. In here, we can say that this is the next test, and this triggers if all other tests fail. Okay? You can only have one else inside of a big statement like this. If, else, if, else. Okay? You can't do if, else if. You can't do that. Okay? It's got to be in this thing. Okay? Now this is one big statement because else if cannot exist alone. Okay? An example would be if I didn't have this. Watch. If I don't have this, don't do this. But if I don't have this, and if I do this, else if, right, will not work properly. This doesn't work. This is going to give me, you know, potentially an error, right? Because there is no way. It tells me else cannot start a statement. It tells you right there, all right? And same thing with if this didn't exist. Okay, if it was just else like this. If I ran this again, it's going to tell me the same thing. Else cannot start a statement. You can't do this, right? Else's, as an example, cannot live alone. They must start with an if. If is the condition. Else is the alternate. So now I'm creating alternate paths. If I enter door number 1, I do this. Else, if I go to door number 2, I do something else. And if I don't do those, else, I'm still inside the corridor, right, or whatever. That's the trigger condition. That's the default. That's the thing that happens if all else fails, right? Yes?
But this only works for like 3 alternates, right?
So far. Yeah, those are the ones, right? And now all we're testing is string literals with character name. That's all we're testing. We can make other tests, okay? But for now, this is a structure. Here's something I want you to know. Else, the last statement, is optional. You don't need this part, okay? I ran it without before, right? But this, if I put this in, it catches everything else that these 2 don't. Okay? Yes?
I'm a little bit confused why we're putting else in the second one.
Okay.
We have an else in the end.
Else if. It's not just an else. It's an else if.
But,
So if, do this. Else if, do this, else. And else if is on the next check that we're doing. Else if is a whole keyword on its own, else if. It allows me to test multiple conditions. For example, let's do another one. Okay, I can copy paste this one to do this, and I can say that this is now Sarah, right? And I can keep doing this ad nauseum. I can keep going down and test every name in the in a name dictionary. I don't know, some kind. Right? That's 3 tests now. I'm doing 3 tests and then a default. Right? Yes.
I was going to ask, is it kind of like a branch? It's not.
It is branching. I've got 3 possible branches. Imagine I'm in a corridor, and instead of like the character name, I'm looking at 3 different doors. There's a red door, there's a blue door, and there's a green door, right? I look to the red door. Did I go down the red door? That could be a test, right? And if I go down the red door, I'm in a red room, right? With maybe, I don't know, some weird creature in there. I don't know. I'm thinking D&D again, right? I go in the blue door, right? And the blue door, there's no room at all. It's an ocean, right? And I go down the green door, and the green door is space, right? 3 different options that give you different kind of solutions, right? And why? Each door I open is a gate that I pass through, right? And in fact, what's what we're doing here? Every statement we're using is a branch in different directions. Here we can make our choose your own adventure just by these 3 things here. Here's something else where if logic comes into play, right? If it's an enemy, kill it, right? If it's a friend, defend it, right? Those kind of things. If else is very powerful statements. We start programming our machine, our robot, to do whatever we want, right? And like I'm saying, this is the first day we actually have, in essence, a single algorithm, right? So this is one big statement, okay? But as soon as I put in another if statement, if I take this part right here, and I go down here, I have another test, right? Where I can say if character name is Daryl, right? Then, I can put something totally different, like, what are you doing here? You can type whatever you want in there. Whatever you have in here will execute. Doesn't matter what you put in here. So, but this is a separate second test that is not linked to this one at all. All right, this is one big statement because if, else is one thing, right? Whereas if by itself is its own thing. Yes, I'll come back to you.
So could you run else if by itself?
No.
So you need an if statement?
You need an if statement, yes.
I'm making sure I'm understanding it correctly. So the else if makes it part of the first condition.
Yes,
Okay.
yes, it's part of this first condition. The condition fails, then if that fails, what about this one? If this fails, what about this one? If this fails and all these failed, then you always run this one, right?
And then the next if is its own separate.
This next if is starting a new statement again, starting a new branch. As an example. Okay, this is all possible. All these journeys are possible. Let's try this out, right? So if I type something like, Tom, it's going to say, welcome, Tom. If I say something else that I don't capture, I haven't captured Tom, Bob, or Sarah, let's use another name, like Braku, right? Okay, Braku is like some other name was entered, because that's the catch-all default else case that I hit just now, right? Because another weird name, right? And, but if I also did this, if I say something like Daryl, right, it's going to say 2 things here. Daryl's going to say 2 things. Daryl's going to say some other name was entered, and it's going to say, what are you doing here? Let's try this out. Here, some other name was entered. What are you doing here? Right? Why? Because both conditions were tested. Example, all right? The first set of conditions were these ones, right? And Daryl didn't appear in any one of these tests, okay? And then the second test, the second group of tests, which is this one starting here, Daryl did appear. So I run these things differently. Yes?
Oh, don't worry, I don't need help this time.
Uh-huh.
I just decided to type in a different name other than Daryl.
Good for you.
Still going along, though. I just
Awesome.
decided to type in the name of my cat. Named
That's awesome.
Winter.
What's her name?
Winter.
Winter's a great name. I love that name. All right. Thank you. My cat's name is Bear, and she's a white cat. But anyways, let's continue. All right. So again, we're talking about branching. We're talking about almost like little doors, or we're passing through, right? As an example. And right now, in many ways, what we've created is, again, some logic. If this, then that. Else, if not this, then that. If this, then that. If, then. If, then. If, then. Right? And if not, what about if it's not going to happen, right? So if none of this passes, right? Or sorry, if none of this passes, this will always trigger. All right? That's what's going to happen. If none of this passes, this will always trigger. But notice here we don't have an else. We could simply also put an else here as well. Else, right? And we could say something like, if it's not Daryl at the end, right? Because Daryl's a weird one, we can say, welcome, traveler. I spelled traveler with 2 L's, I don't know. But whatever, right? And if we did this, if I press play, right? And if I was to type in Daryl, it's only going to say some other name was entered. What are you doing here? But if I press something normal like Tom, Daryl's not normal, right? If I spit Tom, Tom's going to say welcome, Tom, and it's going to also say welcome, traveler. Both these things, right? And the reason why it's going to do that is because Tom, right, passed this test right here and failed this test right here, right? Tom failed this test. I'm not Daryl, so therefore I'm a traveler of some kind, okay? So this is really fundamental, this understanding, okay? Let's go back to the PowerPoint for a second while we talk about these things. So we're talking about decision making, and we're saying things like this. We're saying you can also test numbers, not just strings, right? So if I enter a value, as an example, and let's try this out. I want to enter values for my my agility, kind of thing, right? So let's try this out. I'm going to comment all this out. This is just for me to demonstrate if conditions. So I'm going to comment this out right now. Okay, comment it out. I'm going to go all the way to the bottom here and then just put the bottom multi-line comment here. So this is all commented out now. I'm going to keep it there for now, and maybe I'll erase it later. So let's suppose that I want to prompt the user for agility, right? And let's suppose also that I don't have a clamp. I'm not using a clamp somehow, all right? So I can say something like this, console.write, right? And I'll say something like enter agility. There is enter agility. And then I can say something like agility is equal to, right? I want to convert to int32, console read line. I want to do that, right? And then I can do testing. Okay, let's do some testing. Ready? If my agility, right, is less than 5, right? There's something I can test. Then console.writeLine, I can do that. Number entered was too low. Okay? And I can also do another test down here where I can say if agility is greater than 50, you can see where I'm going with this, I'm sure, some of you. Console.writeLine, number entered was too high. Because remember I said that I only want you to enter numbers between 5 and 50, right? If it's greater than 50, that means any number greater than 50, 51 or higher. If I say anything less than 5, any number less than 5. That means 5 or 4 or lower. And that means things like negative numbers too also count, right, for this one. So this is also something that you can do. If agility is less than 5, I can type in this. But what if agility is not one of these, right? If it's not one of these, then I can say something like print it out, right? So I only want to print out what your agility is if these things fail. If these things fail. So that means I can do this like this. Instead of testing them separately, I can do this. If, else if, right? So it's one big statement again. And then at the bottom, I can put else. And I can say something like console.writeLine, your agility is, And then what we want to do is use that fancy new way of doing things. What's this called again? I forgot. What is this way of doing things? I can't remember what this is called, right? There's a certain name for this. Anybody? What am I doing here with agility? I'm injecting it, but what am I doing? What's this thing that I'm doing called? What's this and what's this? What does it mean? Anyone remember from last week? Interpolation. It's interpolation. I'm injecting agility inside of my string, and then what it's doing is it's evaluating agility instead of, what's the other thing we did last time before interpolation? Concatenation, right? Concatenation was I use the plus symbol, where I take two strings and smash them together. That's concatenation. This is interpolation, right? So here, if you think about it, it's a very simple statement. If agility is less than 5, this will trigger. Else, we do the next test. If agility is greater than 50, this will trigger. Else, if these two fail, then it'll do this. Okay? Yes?
So, should we have a way to repeat it?
Mm-hmm.
If it was too low or too high?
Next week, we'll do looping. Right? If I give you loops today, some people will, their brains will blow. Right? You don't want that. Go slow. Slow. I tell my dog this all the time. Slow. My dog's name is Odin, the dog father. All right? And he goes slow when I tell him to. He bites everyone else except for me. Okay, let's continue. So, agility is less than 5. Agility is greater than 50. Else, let's see what happens when I put this in here. All right? So again, I'm going to run this code now. And if I go here and I enter my name, we don't care about my name anymore. But we do care about my agility. And if I enter a number like 3, right, which is clearly less than 5, then it says number entered was too low. That condition was triggered because my test passed. Okay? So this condition was triggered with my input because my test passed. Agility was less than 5. So therefore, this condition triggered. That is the door that I went through. Okay? If I try this again, and if I put in another number like 55, then it's going to say, 55, sure. Then it's going to say number entered was too high. That door was, we went through that door, okay? I just entered the number and the name. I don't know what the hell I was thinking. But 55, right? This means this one was triggered, but this one failed. So both of them were, this one was tested actually. If agility is less than 5, was also tested. And I want to talk about this in terms of execution flow, okay? The compiler, your code, will look through each line, right, and go, okay, did I pass this test? No. Did I pass this test? Yes. Do this. And if I pass this test, if one of these tests pass, then this line here is ignored. The else condition only triggers when all the other conditions fail. Okay? That's how it works. So let's try now to see that it's a proper number. Let's try this out again. If I type in a proper number for Tom, let's say my agility is 35, right, and press enter, now it's going to say your agility is 35, right? Because the other two tests failed, it's not less than 5, and it's not greater than 50, therefore the else condition triggered and showed us this line. Are we clear on how this works? Is anyone not clear on how this works? Has anyone got a question on what's happening here? Because my friends, if you don't understand this, right, as we go forward, like I say this all the time, we continue to add things onto our code, right? Agility is a way of doing things. And this is really good, but you know what? It's really cumbersome. Wouldn't it be nice if we could test both conditions at the same time? We're going to get there.
It's testing them in sequence.
But I can test them together. But first we'll get there. We'll get there. Yeah.
If you have a lot that you're testing, and let's say the last thing that you're testing is the one that ends up being true,
Yeah.
will it take a while for it to respond?
It depends on how many lot you mean. Like the computer can be very quick, right? So if you're doing something every frame, so here's something that this can be used for. Did I collide? 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 I can keep doing that, right? Or here's another one. Did you click me? Did you click me? Did you click me? I'm listening for you to click. That's what actually is happening with buttons. When you have a button in an interface, it's listening for a click. It's actually doing this in some ways, right? If I was clicked, then do something. Yes?
Whenever I run it, I keep running the welcome
I don't know. Well, maybe comment it out like I did.
I did.
Well, if you did, then it's going to be green, right? All right, so take a look at this, right? I mean, it's pretty simple. Let's go back to this and talk about this. So we did this already. We talked about this. I know we're early on in our PowerPoint here, but I wanted to go through that a bunch of times to get you to understand the way it works. Pass or fail. I have a condition. I test the condition. It either passes or it fails. And the condition is either true or it's false, okay? That's how you have to think in your mind. When I put an if, I'm testing to see if it's true. If it fails, it skips. And it skips to the next condition, right? Inside of that whole statement, all right? The statement becomes longer if you add an else if and an else, okay? So that's what it does. We talked about this, okay? And again, the idea that this is an expression that has to be evaluated. Score, in this particular case, in the PowerPoint, is evaluated first. It becomes a number, right? So let's suppose score was 50, right? Well, 50 is not equal to 100, so therefore this would be false if it was 50. But first, we evaluate what's here. In this case, when we go back to our code, we're evaluating agility. Agility is the number that I entered. It's an expression that gets evaluated in real time, right? When I go to the if statement. So it changes this. It changes this. This is not, don't type this, but this is what it's actually doing behind the scenes. It's changing this to an if statement that looks like this. If, let's say I enter 35, it kind of does something like this, okay? If agility was 35, okay? It evaluates it and then it compares, okay? Because agility, it doesn't mean anything. It's just a placeholder for the variable name. That's all it is, right? And by the way, you could do that too. Here's something I can do. I can do this. That's also valid. But this, my friends, is hard-coded. This is always going to be false, right? I could do this too, right? But it's always going to be false. Always, always, right? Why would I do this? This doesn't make any sense. Yeah.
Why don't we do equal then greater than 5? Is there
Well, you could. Well, we'll get back to that in a second. We learned how to walk, grasshopper. Then we fly.
okay.
All right? Okay, let's continue. So now we have agility. We talked about that, and we did this idea. This is an expression. That's important to understand that it evaluates the expression. And we talked about the equal operator, okay? Code blocks. I've been kind of dealing with this code blocks, and I did it on the slide. Code blocks, right? What is a code block? This is a code block, okay? So that's a code block. So code blocks, right, is this. This is a code block. And sometimes it's called, a block statement. Other people call it different things. But to me, I'm always going to refer to this as a code block. Code blocks start and end with a curly brace, right? Well, we kind of have code blocks here already, don't we? Take a look way up here, right? We have this code block up here too. This is a code block, right? And we also have this code block up here. This is also a code block all the way down. And this is also a code block, right? A bucket or a container, I like to think of it that way. Some people in other languages call this a closure, right, as well. It's an enclosure. It surrounds, the curly braces is almost like a bucket, like you said, or a container that is full of other code, right? Code blocks have special characteristics, okay, that we're going to talk about. All right, so I want to tell you this, but please do not do this, that an if statement can also run without these curly braces, right? Like, for example, if agility is less than 5, I can simply run the same line, console.writeLine. You can do this too. Don't do this, right? Right? So here's a problem. By the way, this is weird, right? But imagine if I don't have all this. I'm just going to disappear it for a second, okay? I have this. This is valid. It's a single statement, and if statement will do that. Well, this is where it gets into problems. What if you do something like this? You might think that this is part of the if statement. But what if I do another one of these, right? I want to do one of these, and I kind of put that in there, right? And I kind of tab it in. Doesn't that look like this is part of the same if statement? It's not. This is together, right? And this is something completely different. This actually is not part of the if statement. So we never use single statements like this. I know that there are going to be some professors that you might meet in your day. Other developers, right, that actually say, hey, if it's a single line of code, don't use curly braces because it takes too much space up. Or, right, you know, they just think that it should be written on the same line like this, okay, because it's a single line of code, it's one big statement. In fact, this is correct, right, semantically. But it's incorrect for us for coding style, all right? I will never accept you to do this. If you do this, you will not get marks for what I'm asking you to do, all right? This is incorrect. Don't do this. I don't know how many times I can tell you not to do this, okay? But it does work.
Yeah, I guess that's why you wrote don't do this.
Don't do this. Here's also something else you could do. You could also do this, all right? You could do this too. That's also valid, all right? This is more acceptable. This is more acceptable, but also my question to you is, well, why? What are you doing here? What are you saving, right? Huh?
Saving your fingers, you don't just
No, don't do it, okay? Do at least, at the minimum, please do this, a minimum, okay? And my friends, I don't even like this. You know why? Because this is here. This little curly brace right here, it's an intruder, all right? I want to kill it with a laser beam, all right? It does not be there, it cannot be there for me. Some people and some coding styles have curly braces at the end of statements like this, right? There's a problem. What if I wanted to copy paste a new thing in there? I would kill the curly brace. And if I did that, then I might get something like this, which is, oh man, I just made an error in my entire code, right? Something just became an error, everything. And you're like, how come my code's not running? Well, because you're missing a curly brace. You have a closing brace, but you don't have an opening brace. Bad things happen to good people. Don't do this, right? Instead, do this, right? That's what you need to do, and that's what I want you to code like. I know people are going to get mad at you. You're going to meet a professor in the future that's going to say, who told you to do that? And you're going to say, Tom, he did it. Blame me, okay? I have no problem with that. I'll face up to that person anytime, all right? And I'll explain why. And you can explain why too, which is there's no quota on how many lines we have here, all right? This is way more clear than a curly brace at the end, right? And we can always replace it with something else. All right, so this is okay. Do this, all right? Please do this, okay? That's okay to do, all right? But don't do the other one, all right? Back to this. So yes, curly braces. This is a block statement or a code block. I will call it a code block, not a block statement, okay? Just to let you guys know. Let's talk about scope. Oh yeah, this is pretty crazy, right? What if I declare a variable and I did it up here? Well, this variable, which is agility, is actually in this scope. See what this curly brace is? The curly brace does, kind of declares a scope. Scope is a funny word. Some people are freaked out about it, but I want you to think of it like this. Those curly braces decide when a variable lives and dies. Okay, so if I make a variable, if I declare a variable here, it lives and dies in this scope. That's what it does, all the way down here. Right, that's where it lives and dies. It doesn't live out here though. In this land over here, the scope does not live. All right, the variable is locked into the same curly braces it was created in. All right, after those curly braces are done, the system releases that variable back up into the wild. Right? Into the bit bucket in the sky, okay? There is no living after curly braces are done, or if it's declared here, which means this is also a scope, right? Any curly braces define a scope where variables can be declared, live, be used, and die, all right? Which means I can make a variable here. Like, for example, I can make a variable called int, of type int, called my variable, right? Where I can assign it as 0, right? If I try to access my variable out here, outside in no man's land, let's try this out. If I say my variable, right, is equal to 7, right, it's going to go, man. My variable says the name my variable does not exist in the current context. So that's another way to call scope. Scope is a context, right? Scope is a box that you can create variables in, right? So this does not exist. But somehow, wait a minute, agility does exist in here, right? So if I said something like, agility plus equals to 5, right? That's okay. Remember what plus equals to? What does that do? That was from last week. What is agility? What does this do? Agility plus equals to 5. Come on, guys. What does that do? Adds 5 onto agility, right? Plus equals is a shortcut that says agility. This is actually like writing agility is equal to agility plus 5. That's the same thing, right? Remember last week? This is called, I want to add stuff on to agility, right? If you forgot this, the shortcut for this is plus equals to 5, like this, plus equals to 5. That's the same thing. Agility plus equals to 5 is take agility and add 5 to it, okay? There was another thing we could have done with agility. We could also have said plus plus. What does this do? Come on, guys, last week. Increases agility by 1 or increments agility, right? And if we did minus minus, right, like this, minus minus, decreases agility by 1 or decrements. Those are the words, right? I can do that in here. Wait, how is agility available in here, but my variable is not available out here? Well, the if statement exists inside of this context, this scope, because, remember, we have a box within a box within a box. If I declare something in the outer box, the outer level, it's available in the inner level. Okay? But if I declare something in the inner level, it's not available in the outer level. Yes? Call it drawbacks. Yes, there are drawbacks to everything we do, but there's also advantages. But basically what we're doing is with this, with our context or scope that we're creating, it is another extra thing that the compiler has to figure out. So the more of that you have, then of course it can figure it out. But the compiler is very fast. Like our systems are so fast. But these little switches, these little gates, if you will, or doors we have to pass through are like really, really quick. Remember, I can do millions of computations every millisecond, right? So, I mean, this is like this little toy program over here is no problem. Okay? So, let's go back to this. So you can see that this is no good. This scope that's out of water, I want you to think about it only lives and breathes in here. Somehow, toxic atmosphere for this variable out here, okay? This variable in here, it has a spacesuit, right? It can live in here and whatever, but out here, nah, it's just allergic. It can't live out here. It'll die, right? And so it'll tell you that. It'll say, like, if you ever get an error like this, it says, my variable does not exist in the current context. It means it was created in some other box, right? And not in this box, right? Not in this context. So that's something about scope. Scope, right, is inside of these curly braces. Okay, just to let you know. Now, there are some languages that actually this is not true. Okay? In C# it's true, but there are some languages out there that when you declare a variable anywhere, right, it's available anywhere. JavaScript is that language again. I know I mentioned this earlier, and you're like, what the hell is that JavaScript that's so bad, right? Yeah, because JavaScript is a weird, very loosely typed language that's very loosey-goosey, but also gives people flexibility, right? See, structure is good, but structure is structure. I am telling you to do things in a very opinionated way. You must do it this way. If you do it this way, it doesn't work. If you do it this way, it doesn't work. If you do it this way, only this way, then it works. And languages like JavaScript allow you to do things in a bunch of different ways. Positive, flexibility. Negative, you get yourself into a hole, right? And you're like, wait, how come it's doing this? I don't understand. It's doing what you told it to do, right? Which means if you told it to do something that's garbage, it's going to do garbage, right? All right, so this is no good. This is the variable. So, but if I took this variable, I'm just going to show you this. If I took this variable declaration and I pulled it out of here and I put it in here, like in this scope, up here, outside of these curly braces, we're good, right? Because even though it's below this thing, it's still out here in this box. And I can even do something with it in this box. I can say like my variable, plus plus, as an example. And then maybe I can say my variable here is plus equals to 7 instead of like equal to 7. There we go. So I can do that. I can use it in here, but I can't use something from here out there. Yeah.
So inside this curly brace, if you do my variable plus plus, the one that you put outside of it at the bottom won't remember what was in those?
It will.
Or will it?
Because I've declared it out here, it lives in this scope. So it means that it also exists here.
Okay, so
right? Once I declare it out here, it lives in this bigger box, right? But if I declare it in here, it doesn't live down here, right? Once these curly braces are done, it's over. Yeah.
Okay, so why is that? Is the if statement on its own?
The if statement's its own statement, but the if statement is special because it has its own little box, the curly braces. The curly braces are special for the if statement. You can't do that with variables. I can't make a little scope for a variable, right? But I can make a scope for an if statement. If statements are special, right? And we're going to see other special things like that next week with loops. Loops, as you're going to see, have also their own little scope where things live and die, which makes sense, by the way. Okay? And so do functions. Functions also have their own little scope, which is what's happening here, right? Because we're looking at it, and if you notice, we're inside the main function, which also has its own little scope. Make sense?
Okay,
Yeah.
so just to clarify, if I'm making a variable, it has to be in the main scope.
No, it can be here, but that means it lives and dies in here. You can make a variable that has a use in here. Maybe you want to declare a temporary variable. You want to do something with it, calculate something, and then when you're done, it dies, right? But yes, you can do that. I mean, otherwise you wouldn't be able to declare a variable here in the first place. We can. If we can, that means it solves a problem, and the construct, my program, which is a general programming language, allows me to do these things. And if it allows it, at some point, it solves a problem. Okay? All right, let's move on. So now we know about scope, and it kind of talks about that here. One thing that we say here is the variable no longer exists after it goes out of scope, right? We can say that too. So here is an example of that, where we have grade that we declare here as a character. Notice this is only a single character, so it has single quotes, not double quotes, right? That's the way we make a character literal, a car literal, right? And then notice grade is red because grade was tried to be used outside of this scope, right? This is the scope that we created, this curly braces, and it was declared here, but we're trying to use it outside of there, which means it's an error. Can't be done, okay? Next, and this is what we can look at. We can see that boxes within boxes within boxes. The if block has its own scope, which is where grade is, right? But if I pull the grade, like I said out here, suddenly it becomes okay, right? Which is what I said. And then you can see grade now is part of the main scope, which also exists inside the if block. So if I have an outer box and I have inner boxes, just to say this again, if I declare a variable in the outer box, it lives inside the inner boxes too. Okay? Inner scope. Okay.
You say it's like layers in Photoshop or something?
Layers, yeah, you can say that, layers as well. Here's something else about scope. You can declare the same variable twice. Yeah, because remember, these variables live and die inside these scopes. So after these braces are done, there's no more grade, and then I declare it again, right? Remember, because it lives and dies inside these curly braces, I can have the same name twice. I would never do this, right? Again, going back to what we said last week, which is just because I can do it doesn't mean I should do it, right? This is really bad coding because it's confusing. You're like, wait, why did that? Don't understand. But it's possible is the answer, right? So avoid this. We try to avoid this thing because we don't want to have two variables with the same name in different scopes because it's confusing to the programmer. People look at this and go like, but why, right? But it is possible. And this is a good example of a test. If score is equal to 100, if it passes, if this is true, then the string grade is an A+, and then console write line the grade. But then I'm also doing console write line down here, and if I'm duplicating, why don't I just console write line down here, right? Well, because grade doesn't exist. It only exists here. Why? It should probably exist out here, right? So, so that's how it works. I know this can be confusing for you. I know it can be, right? But because we're learning about conditional statements and scope at the same time, and then whenever we learn two things at the same time, it's cognitive load. Your mind is trying to deal with two concepts at the same time, but they're related. There's no way around this, okay? All right, next. We talked about the else statement, which is a counterpart to the if statement, and it must follow the if statement. It cannot live by itself. So you cannot have an else statement alone, okay? That's part of what it is. And it is an alternative just in case the if statement fails, we go and hit the else. That's what happens. We talked about if-else statements where you can do multiple tests, as well. We talked about this already. And now there's some new operators I want to talk about. It's not just equal we can do. We can do not equal, less than, greater than, less than or equal, or greater than or equal. Those are all positive or possible operators inside of your tests. Let's try this now. So if I go back to this, I can say, well, what if it's less than or equal to 4? It's the same thing as, right? This is the same thing as, right? Less than 5, isn't it? Is less than or equal to 4 same thing as less than 5? Right? Well, actually, it isn't, but functionally for us, it works the same way, right? So less than or equal to 4 says if it's equal to 4 or less than 4, then we do this, right? As an example. And in effect, it's kind of like this. So less than or equal to, right? Here's the other one you can say. What if it's not equal to? You can also do this, not equal to 4, right? Not equal to 4 means it can be any number else other than 4. Anything else other than 4, this would be okay. That's what not equal to 4 means, right? Okay, not equal to. So there's equal, not equal, greater than, less than, greater than or equal, less than or equal. Just like in math, actually. Yes?
In regards to, like your slides had grades,
Yeah.
how do you do it if it's between?
Coming. We're coming to that. I'm going slow because we're talking about scope, and then if I did the other thing, you'd be like, wait, what's this mean, right? So, so agility is not equal to 4. We can test that, and like I said, we can test greater than or equal to, or less than or equal to, as an example. And we can also use a Boolean as well. This is kind of interesting, where I can define a Boolean variable like this. We can say something like, correct entry, or correct value, and we can say the correct value is equal to false, right? Here's something we can do. And if agility is less than 5, we can say, like, let's go back to our original statement, is less than 5, then we can write something like this. I'm just going to clean this up so you can see it. We can write something like, what was that? Less than 5, thank you. If agility is less than 5, right, and we have our correct value is false, starting off, then we can say something like, something, it's still false, right? So we can say something like our console write line can say, number too low, like we said before, right? That's what we did last time. So this one statement. And I can also test to see, like we did last time, else if agility is greater than 50, that's also wrong, right? It's trying to give me suggestions that I don't want. Number is too high. I made this different than before, okay? And then we can also say else. Couple things. We can say that if this is true, we can say like console write line, just like we did before. Something different, like you entered this, right? And I want to put agility in here. What am I missing to make this work? Yeah. What am I missing? Yes. $, which basically says that this is interpolation. If I don't have the $, it won't work, right? You enter this, but I can also say here, another statement, where we can say something like my correct value is equal to true. So here my correct value remains false. Here my correct value remains false, but here my correct value suddenly changes to true because I failed these two negative tests. I'm not too high or too low, right? Kind of thing. I'm just right. I've entered a number that's between 5 and 50, right, as an example, and my correct value suddenly turns to true. This, a lot of times, we call it a switch, right? Or sorry, almost like a flag, okay? Even though it's a Boolean in our minds, we've kind of like turned a flag on. Yes, we're true. We're good. And then I might use this correct value somewhere else, where if I have a correct value, I can do something else. I can check for that. I can do something like down here, I can say if correct value, right? If the correct value, if it's true, right? If my correct value is true, then I can say something like down here, I can test for that. I can say console write line, everything is good, right? Okay, if my correct value, else, I can do that too. I can say something like, the world is ready to blow up. Right? Right? Bad things happened, right? You didn't do something right. And you got this, right? So this is kind of a way of thinking. I can declare a Boolean, right? In here, a Boolean value. Boolean, remember, it only holds true and false, only zeros and ones. That's what it holds, right? And then it starts off, we started off as false, right? We started off as negative. It's failing, right? And then these two tests to see if the number is too low or too high. If they're too low or too high, then it still remains false. However, if it fails these two tests and it's proper, correct value changes to true, and then I can do a test down here that tests correct value, everything is good, or the world is ready to blow up. Let's try this thing and see what happens. So if I kind of write this in and I kind of do something like, I say like Tom, right? And then my agility is like 52. What's going to happen?
The world's gonna blow up.
It's too high. It's going to say it's too high, number too high, and the world's going to blow up. Ready? Let's see how it happens, right? Number is too high, the world's ready to blow up. Right? Why? Because it passed this test and failed this test. Does that make sense? I know these are rudimentary things, and you're like, Tom, move on. I get it. I get it, Tom, right? But I got to talk about this, because if I don't talk about this, then when I do something like this, it might be confusing for some. Damien, you okay? Damien, are you okay?
Yes, it's just that for whatever reason, when I tried to do the vigor thing with the Boolean stuff,
Mhm.
which now is completely useless to me.
Mm.
It just doesn't work. It's just
Okay.
there.
Hold on. We'll get to it.
Unless maybe I
Mm.
add something.
Yes.
I put the correct value because it still writes the world is ready to blow up and everything is good or something.
Did you set it to true here in the else statement?
Yeah, oh, I put false.
Ah,
Yeah.
that's good learnings,
Yeah,
right?
yeah.
Hey guys, you know what?
Fix it.
Failure is a good teacher, right? If you mess up,
Yeah.
please mess up. This is a great place to mess up now, because then I can fix it with you guys and correct your logic, all right? So this is the idea. The idea is that we can do multiple tests. This is one group of tests, guys. I'm going to say this again. This is all connected, okay? Because we have an if, else if, and else. Remember that else if and else cannot live on their own, all right? You must have an if before it. And here you have another test, if and else. I start a new test with a new if statement, okay? If I have two if statements in a row, they are not connected, ever. They're always separate. You always run every single if statement that I put in. Doesn't matter how many I have. I can have 100 if statements and I'm going to check them all. However, here, what's going to happen is, if this test passed, I don't check any of this. I ignore the rest. I only execute the test that passes in this block, and the rest of it, I ignore. Okay? So if I fail this one, then I run this one. If I pass this one, then I ignore this one. Okay, this is also something we have to think about. Also, I want you guys to look here, and I want to ask you this question. How many scopes do I have here that you can see? That you can see. Only that you can see. There's more, but how many scopes do I have here? Yes? 5. I have one scope here, another one here, another one here, another one here, and another one here. And guess what? I can declare variables that live and die in all of these scopes. Okay? They're all little boxes. Yes?
A more general question.
Yes.
Will our game basically be different scopes, like the menu will be a scope, the game itself will be a scope.
Yep. Every class is a scope. Every method is a scope, right? Yeah. Well, yeah.
I'm confused about the bool where you put correct value equals false.
Uh-huh.
Then we do correct value is true, but we didn't define what true is.
True and false is a literal.
Okay.
True and false is just like 1 and 2. Like instead of a numeric literal, this is a Boolean literal. False and true are part of the system.
How does it know when it's true or false?
You're assigning it right there. I'm assigning this. I'm assigning this to this. This is not an equality statement. This is an assignment statement. A single equals means take true and assign it to correct value. Correct value is a Boolean type, which only takes true or false. All right? That's what a Boolean type does.
And it knows it's false when it's not that one that we assigned is true.
Well, I set it to false here. I never changed it. I haven't changed it here. I haven't changed it here. And unless I come to this point, it's going to remain false because I'm going to ignore these things. Right? If this passes, then I ignore this stuff. And if I ignore this, then it never gets set to true.
Yeah, I get it.
Make sense?
Yeah.
Questions else around this thing? This is, again, very basic. And again, if you get this already and you're like, move on, Tom, right? Please, patience, my friends, patience. Because I got to go through all the questions and make sure everyone's good on the same page because later on I'm going to make some assumptions that you know exactly what I'm talking about. Yes?
I just want, looking at it, I'm confused why it knows that correct value is true there without saying anything. Like if correct value and then calls everything is good.
Here?
Yeah.
Oh, you mean you're expecting me to do this?
Yeah.
Ah, I was hoping someone would say that, right? This is the explicit way of saying if correct value is true, right? Because we're making comparison. Correct value evaluates to whatever the value is, and then we do comparison. This is the comparison operator. We're comparing this on the right side with the thing on the left side, right? If I hover over this, it tells you I'm comparing the left with the right. Here's the right, which is a true, which is a Boolean literal, which is true. Correct value converts to a Boolean literal that is true. However, remember that if I just put this, the reason why that worked is because what am I doing here? I'm evaluating correct value, right, as either true or false. It switches. So let's suppose I came to this point and then correct value was true. Then I would sub in correct value as true later on, right? And remember that all I'm testing for is a true and false condition here. So this is also correct, right? Because I can just simply put true here and it works, or false and it fails, right? The thing in the parentheses is a test to see if it's true or false. Here, I'm explicitly telling it that it's true, and when I evaluate it, it's always going to pass. It's always going to run. If I do this, it's always going to run this one, and it'll always ignore this one. In fact, you notice that this is grayed out. If I hover over, it says that. It says unreachable code, because this is always going to happen, and this is never going to happen, because this is always true. Yes?
So it automatically knows what true and false mean. Like those words, it knows what that
True and false is part of the system. That's like 0 and 1, okay? It knows what those things are. In fact, like I said to you before, Boolean, or true and false, is the way that we can calculate anything in the entire world, if you think about it. True and false. Let's talk about quantum computing. I digress. Quantum computing, right? Here I have a Boolean value that can only be true and false. In quantum computers, it can be both. Both true and false at the same time. And it comes from that Schrodinger's cat experiment way back in the day, right? I don't know if you remember physics, but Schrodinger's cat, right? You just put in a cat in a box with poison, right? And you don't know if the cat is alive or dead, so it could be both. Right? Yeah, that's the physics part, right? Quantum worlds, or the many worlds theory, right? Both, the cat lives in both states, both alive and dead, and quantum computers can do that. It uses, instead of using a variable like true and false, it's both. And so where this is really crazy is, in the future, encryption, which basically tests to see if things are true and false, like your password, can be both true and false at the same time, which means current encryption that we have today will be useless in the future with quantum computing. But we digress. Let's go back to this, all right? So, yes, basic stuff we just talked about, this kind of stuff, and we talked about using a Boolean to do this kind of stuff, where we can test one or the other. Here, it didn't assign a value to the Boolean. Here it did. It kind of said that either true or false is here. Here I've already assigned false, and here I assign true. And what you're saying is that how come I didn't do this? This is explicit. This is telling you to do the test. But remember, when this evaluates, correct value evaluates, it evaluates to true or false, and so therefore I can test it this way as well. Both are true. So this is like the same as, you know, if correct value is equal to true. Same thing, okay? It's the same. Why? Because correct value, it evaluates correct value, and then when I evaluate it, I do a comparison. That's the comparison operator, equal, equal. I compare the right side with the left side, and if it's true, if it passes, then the whole thing is true. All right, let's continue with this insanity, right? We talked about this too. There's also a logical operator. So we talked about relational operators, like where we said things like greater than, less than, greater than or equal to, not equal to. Those are all relational operators, right? But there's also logical operators. Logical operators are true gates that we talk about. The first one that I want you to think about is the not operator, when I use the exclamation mark. So for example, if I said something like, if not correct value, anything that comes after the not, the exclamation mark, makes whatever this was, it reverses it. If it was true, it becomes false. If it was false, it becomes true. It negates the value. It inverts the value. Lots of ways of talking about the same thing. I'm going to say that this is like saying, if I'm not the correct value, everything is not good. I would probably put this, I would reverse these things. I put this up here, right? And that one would go down here, right? Because if it's not correct value, then this would pass. What if it was false, it would be true, right? If it's not the correct value. If it's true, it would be false, right? And therefore, it'd be reversed. This can be confusing at some point, but it's also something that we can use to test. We can say like, hey, if it's not good, then don't do this. If it's not good, well, I want you to print out some errors, you know, or whatever. I can test if something is not good, if it's not true, right? And that's what I'm testing here, okay? If it's not true, or the inverted value. So that's the not condition, okay? The not operator. So true becomes false and false becomes true. I just turn it around, right? I also have two more operators because you guys asked about this. You were asking, how come I can do those things together, right? The and operator is ampersand, ampersand. So double ampersand is the and operator, and the or operator is, you know, pipe, pipe. That's what those are. Those are pipes, right? So you find the ampersand operator above your number 7, and you find the pipe operator above your enter key. Okay, that's where it goes. So if you press shift above your enter key, this little backslash, it becomes a pipe character. That's where it is, right? So double pipe or double ampersand, that's either and or or. Now we get to something else called discrete math. Here we go. If I have an and, that means the left side and the right side both must be true. When I evaluate the entire expression, both sides must be true in order for the entire statement to be true. Okay? If I have an or, either the left side or the right side could be true, and the whole thing is true. Okay? Does that make sense? So here's an example. In order for me to go upstairs to buy a coffee, right? Here are the two conditions that must be true for me to get a coffee, my little liquid gold right here, right? I must have money, and there must be coffee, right? If there's no coffee upstairs, if they're out of coffee, my liquid gold will not happen. I will not get it. Both conditions must be true. They must have coffee upstairs, and I must have money to pay for that coffee, all right? If I don't have money to pay for the coffee, I can't get it, even if we have, coffee upstairs. Make sense? All right? Yes?
So it has to be.
They both must be true. Both conditions must be true, the left side and the right side. I can marry two conditions together. I can have a condition on the right side in parentheses and a condition on the left side, two different conditions, and I can test them with a logical operator in the middle. Hence what you asked. right? So if I say something like, instead of doing this, here's where I can marry these two things. If agility is less than 5, and, right? Or would it be or agility is greater than 50, right? And I want to put these in brackets, like outer brackets, like they'll look like this, okay? This is how it would look, okay? Then I can say number entered was either too low or too high, okay? This is a condition. I have two conditions. I have the left side and I have the right side. This means either one or the other is a problem, is an error. Okay, that's what it means. But if this one is, it's correct. So I'm checking to see if both are failure, right? Either one or the other one are failure. If either one fails, the entire thing is true. If this fails, if this is true, just this one, right? Then this whole thing is true, right? Because I have an or in the middle, right? Either one or the other, it doesn't matter which one. If one of those is true, the left side or the right side, the entire thing is true. Okay, I could change this though. I can write it differently. Here's where I can write it differently. I'm just going to copy paste this. I'm going to comment this out. This is why I do these things, right? I can comment this line out for a second. And let's replace this line with an alternate way of thinking, okay? If agility, right, is greater than 4, right, and agility is less than 51, right? Right? Then I want to do this, not this. So let's swap these things around a little bit. So I'll do it like this. So put that scope down there and move that scope up there, and we're good to go. This is the exact same thing that I'm doing, but I'm doing it in a different order. Now I know your brains are thinking about this, and you're thinking which one is better, right? The answer is it depends. I'm sorry to tell you that, right? But first of all, does this make sense? So agility is greater than 4, and agility is less than 51. That's your range that you're checking. You're checking to see first. You're doing two checks. Is my agility greater than 4? Pass. True. Right? Now, because it's an and, I gotta check this one. I have to check both. With an or, the first case that I had, you only have to check one. If this is true, the whole thing is true, right? But here, if this is true, we still have to check the second side because both have to be true, and if we want the entire statement to be true. Okay? If agility is greater than 4 and agility is less than 51, that can be true, right? If I have a number like 35, 35 is greater than 4 and less than 51. Make sense? So then I'm going to say everything's good. Otherwise, it's bad. Let's try this out. See if it works. So if I put a number like, if I say, hey, Tom, your agility is 55, it's going to say the number entered was either too low or too high. The world is ready to blow up, right? And if I do it again, if I run it again, and if I say something like, well, the number now is 35, like I said last time, I'm just testing 35. Let's test another number like 29, right? I'm okay. You enter 29, everything is good, right? Because I'm within that range, greater than 4, less than 51. I could also write it, one more time, wait. I could also write it differently. I can write it like this. If you don't like this, greater than 4 and less than 51, because you don't like, these are the boundaries, I could write it like greater than or equal to 5, right? Less than or equal to 50. And some people like this more. Why do people like this more than 4 and 51? Yes?
So understand decimals, you put in like 4.5 as the answer.
Okay, if it was a decimal, but we're testing integers, but that's not the reason. It's because, this is really clear, right? 5 and 50 is what I'm testing for, and I can use greater than or equal to test both, right? And so I'm not testing for the lower or the higher end, I'm testing between, and we're talking about now minimum and maximum. Here's the minimum, 5, and here's the maximum, 50. Here's something else we can do. Let's try this. What if I said that in the future, we don't know what the minimum and maximum are going to be. I can actually have those two values here. Instead of hard-coding them, I can say int min is equal to 5, int max is equal to 50. right? And if I did that, I can replace these by min and max. Could I not? I'm making a test to see if the agility is greater than or equal to min and the agility is less than or equal to max. And this way, I'm not hard coding. I can expose these. If you're playing with Unity, I can expose these and change these values. And this way, if the user, if the developer wants not to be, doesn't want to make 5 or 50, let's say they want to say 10 or 50, then it'll still work, right? It's more flexible this way. Yes.
Sorry, I'm trying to figure out.
Yeah.
That would be better because if you're doing it like that, once you change that one,
Absolutely. If I use min everywhere and max everywhere, right? If I change min and max here, I change it everywhere, right? But if I have the actual numbers here, they're hard coded, which means I have to change all of those numbers. And a good example of this is if I test other values out. Let's do another one. Okay, so I want to do this, right? And let's just put these a little higher. Okay, so I'll put these values a little bit higher up, like up here, because these are the values that I want to enter, and maybe even up here, because these values here are part of my declarations. I like putting all my declarations at the top of my code, pretty much more or less before anything else. So actually, even this stuff, I don't like putting this stuff here. I would rather do all my coding under all my declarations. So typically what I do is I do all of my variable declaration here. So this is where my variables declaration is happening. This is where I'm doing it up here, right? And this would be for your, character's name. Okay, so I can kind of code that a little bit, right? And then as I come down, I start doing something. I can kind of code this. I can say something like change the console colors, right? That's what I'm doing here. And then I can comment, change the console title, right? And then I can prompt the character. I can prompt for agility. Here's where I'm going with this, so you can see it all in its glory. And now I can, let's not use this part, because this is like, I did something over here. And let's say, for example, I don't really care about, I don't care about my correct value for now. Okay, just so we can have this thing. But I do care about my, instead of my agility being like this, only like this, to your point, what if I wanted to do the exact same block, the exact same check with, let's just grab all this actually, prompt for strength now. So I need to do all this to prompt for strength, right? So prompt for strength, right? So I can say enter strength. And then I'm going to convert strength to whatever I enter, right? And then I can say if strength is the same, right? Right? So why am I showing you this? Because take a look at this code, right? If I had hard-coded values, to your point in here, I'd have to change all these ones here and these ones here, where up here I can change those values up here, but they change for all of them. Does that make sense? Now this looks like complex code, but I'm just repeating myself over and over again. I'm not really doing anything new. This is just the same stuff. So now I'm prompting for both agility and strength. Yes?
If you wanted to have different max and mins for the different actions.
Then you'd have to have, you could, but that means you have to define new variables for those.
Oh, okay. I was gonna ask if we could do the min, so that would be in each prompt for strength.
Well, you could, or you could do something like up here. Let's suppose that's a good question. So the question was, what if I wanted to do different mins and maxes for all entries? Well, I could start off with, let's say, for example, the default one is 5 and 50, right? But then when I get to strength, I say the minimum is, I can say that the min, right, is for strength is 30. So I can't enter anything lower than 30 for strength. I can do that. So now this min is different than this value of min. When it evaluates, this evaluates as 5, and down here, because I've set min to another value, it evaluates as 30. That's weird, but yeah, you could do that, right?
That wouldn't redefine what min was
No,
comes back
because
up
you're
again?
because it's happening lower down in the code. You're not going to come back up to agility. There's no loop here. It only fires once, right? Remember, it goes through all these lines of code once.
So if you were to ask it to display agility again after you did that, it would come up as 30?
It would still come up as whatever you entered agility as. But if you asked it to enter agility again, and if the min was changed, then the min would be 30, right? All right, so this is kind of the idea that we're doing. We can have values here, and the value would evaluate. So this statement is like saying this. Okay, I'm going to write it out so you can see it. Okay, this is like saying. Okay, here's how we would say this. If agility is greater than or equal to min, and I'm going to put that in big letters, and agility is less than or equal to max, then do whatever you're going to do, right? Okay? I'm writing this out for you so you understand what the computer is trying to figure out. It's trying to evaluate, right, what agility is and what min is. It does those first. It converts them into true and false, right? It converts them into values, like numbers. So example would be if I entered 35, is 35 greater than or equal to 5? Yes. So this test passes, right? And then the ampersand says I need to test the other one too, because both expressions need to be true in order for both things to be true, but this whole thing to be true, right? So then I test the next one. Agility is 35. That's the one I enter, but is it less than or equal to 50? 35 is less than or equal to 50. That's true. So because both conditions are true, then this whole thing is true, and it runs this code block. Otherwise, if one of these conditions is false, then it fails and it runs this code block. If this passes, it ignores this code block. If this fails, it ignores this code block, right? And it runs this one. Okay? This is branching. If, else. Do I have line of sight? No. Do I have enough health? No. You know, am I close enough to attack? No. If I'm not any of those things, do I see it? If I have no line of sight with an enemy, patrol. Okay, I'm patrolling, right? Wait, do I have line of sight now? Yes. Okay, am I close enough to attack? No. Okay, if no, move closer. Am I close enough to attack? Do I have line of sight? Yes. Attack. Did I hit? Yes. Damage. No. Nothing. Right? It keeps doing that over and over. This is like how we make AI, guys. Right? This is how we can do any decision in the game. Right? And you can do that kind of stuff over and over again by making these condition checks. All right.
It runs that every frame then?
Every frame, well, you could. This doesn't, but in the future, yes, we could make a program that runs every frame and an update loop, and then it would do that.
That would be for like what you just explained.
Yeah. All right, so that what we talked about logical operators here, right? And I want to get through this. I'm going to kind of go through it. So we have expressions, but we have this idea of a sub-expression. We have the whole expression, and we have sub-expressions. And the whole expression is what we put here. This is the whole expression, right? And there are two sub-expressions. This one, hold on, and this one. Those are two sub-expressions. Yes, Damien?
Okay, so I did pretty much everything exactly for the vigor attribute that I did for strength in mind, but
Mm-hmm.
but even if I did the same thing, it just doesn't want to do the vigor like okay, let me explain.
Let's do this after. I got to move on because I got more to talk about today, right? Otherwise, we're going to be bogged down, and I can answer your question after class, okay? Thank you. All right, so now we're moving to logical. We can also nest ifs. This is a weird thing. I can put a curly brace, a block within a block, right? I can do this too, right? Nested if statements. Here's an example. I got wounds of 15 and I got toughness of 55, right? If my wounds are less than 0, then I go inside the second block. So I test first to see if this first thing works. Is my wounds less than 0 or less than or equal to 0? No. So then I skip this whole thing and go to here. You still live, right? How about if my wounds were not 15, my wounds were like 0, right? If my wounds are 0, so this test pass, then I check this. Is my toughness less than 0? Less than, if it's not, I do this condition where wounds are gone but toughness is keeping you alive, right? As an example. If both of these two are 0, then I do this condition, which is wounds and armor are 0, and this instead of armor it'd be toughness. This is actually incorrect. Wounds and toughness are 0, and you're dead, right? Assuming that you need wounds and toughness to stay alive, right? Both those two conditions, whatever they are, right? By the way, you could write this differently. You could write it on one line. You can say if wounds are less than or equal to 0, and it'd have to be and because both those things are going to be checked, and toughness is less than or equal to 0, then wounds and toughness are 0, you're dead. Otherwise, wounds are gone, but toughness is keeping you alive, right?
But it wouldn't know which one.
Wouldn't know. No. You can still test inside and see which one, right? You can do the initial check and then you can go inside and do more, right? But yes, this is a nested if statement. Nested if statements are very powerful. However, I'm going to put my hand up and say, be careful. This can lead you down a rabbit hole of checks. So I'm going to check this, and then inside there I check a bunch of stuff, and inside there I check more stuff, and I can put like an if statement within an if statement within an if statement with unlimited times. Unlimited. I mean that. Like there's no scope limit. How many times you can go, keep going, yeah.
So would it be beneficial to group as many checks as you can?
Yes, grouping checks is good, and this is where we go down to Boolean logic, right? Now, this is not the topic of this course. Boolean logic is the topic of another course where we do things like optimization. Here, we're not optimizing. Here, we're just talking about yes or no, true or false, does it work or not? But optimization, there are many optimizations. For example, here's an optimization. I always put the first condition that I want to check that's critical on the left-hand side. Why? Especially when you're looping in a game, right? If I have two conditions, right, this one and this one, the one that I want to check most should be the leftmost side. Why? Because if this one fails, then I skip. Otherwise, I got to check twice. I got to check this one and this one. I'm doing two checks. Here, if this one is the critical one and I care about this one, I only do one check if it fails, right? So that's why it's important to think about how you position your sub-expressions. Moving on. Chug-a-lug. Here we go. The ternary operator. This is a new operator that we have to talk about. The ternary operator is interesting because it has a different set of syntax. Here's the conditional expression, whatever that is. We have a question mark, right? And then an expression if it's true, followed by a colon, and then the expression if it's false. So it looks something like this, right? Like this. Yeah, I'll zoom in there so you can see it. So here's text to display. Is my score greater than 70? The question mark says anything after the question mark is what we're going to return if it passed to here. Okay, I'm going to actually take this and assign it to this text to display. Or if it's false, I'm going to take this and assign that to text to display. So when you first look at this, you're like, wait, what? Right? What? So this is the ternary operator. And the ternary operator is useful when we have an if-else. It's exactly if and exactly else. And there's no other case. We don't have if-else, 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 if. Just two things. True, false. I have line of sight or I don't. Kind of thing, right? So how can we use this in the code we've written, right? Well, we do have an if-else right here. Here's an if-else. So instead of writing it big like this, by the way, I'm not going to suggest to you that what I'm going to write here, you should do. I'm just telling you, you can do it, right? Instead of using this scope, I can do this. I can say, well, if this is true, right, as an example, then I want to do something. Let's suppose I have another variable called, a Boolean, which is the correct answer, correct value, again, right? And I can say that I want to figure out the correct value, whatever that is. I can say something like this. Instead of an if-else, I can write that like this. I can say correct value is equal to, and then in brackets, the condition. This condition right here, right? I can do this. This is an actual thing. And then, if it's true, right, then I can put the correct value as true, or I can put the correct value as false. I can do that. So true is a literal. It'll be assigned to correct value if this passes, or if this test doesn't pass, then false will be assigned to the correct value. Does that make sense? Woohoo! Right? Blow your mind? Yeah, I know it's hard to look at, but this is called the ternary operator. I'm not going to talk about it today because it's mind-blowing to some people. It's a lot of syntax that you're looking at, I don't understand this. But in the future, you will see me use this thing. By the way, the compiler really loves this syntax. Loves it. It's faster than if you do this, right? Way faster. So if there's an if-else, and we can possibly set a value, this is the way to go. Okay? Ternary operator. Well, except we're not doing that today. I'm mentioning it here so you know what it looks like, so you've heard about it, you heard about the ternary operator, but I'm not going to actually do it. Let's talk about switches. So switches, imagine if I have a bunch of if-else. If, else if, else if, else if. I have a bunch of if-else. Oh my God. The whole page is a bunch of if-elses, right? That can be really hard to do, right? Hard to input, okay? And switches are like railroad switches. I have a train, and I have multiple tracks, and they're going to the station, and I don't want them to collide, right? So I kind of throw the switch, and all of a sudden the track goes, and it moves the train over in this track, right? And that's how we can avoid collisions, right? These switches in when it comes to trains, it's automatic. It usually some kind of like detection. Oh, there's a train already in this track. Whoop, it's going to switch you to this track over here, so you don't collide with this one. The idea of switches take the place of if, else, if, else, if, else, if. If I have a single if statement, don't use a switch case, which I'm going to do right now. But if I have multiple if statements, if, else, if, then I might as well use a switch because sometimes it's a lot clearer what can happen. Let me give you an example of that, right? So I have a menu. By the way, you are going to make a menu for your in-class exercise 3. We're going to start in-class exercise 3 in a few minutes, right? I have a menu, and I want you to select your menu. As an example, I want to select, kind of a value. So if I select 1, then I rest. If I select 2, I pillage the port. If I select 3, I set sail. It's choose your own adventure, right? That's what it is, right? What will the plan be, Captain, right? And you just, whatever you decide. Well, how do I make this happen? I could do it with if else. That is definitely something I can do. This is an example. Here's my choice. I get the choice from the console. If the choice is equal to 1, then I write, you rest, then recover your health. Hey, cool. If the choice is equal to 2 or 3 or 4, and if it's some other choice, maybe I don't understand it. Apologies, I do not know that one. I'm only listening for 1 to 4. 5 doesn't make any sense to me. Or 6 or 7 or 9 -1 or something else. Make sense? This is okay, but it's if, else if, else if, else if, and I'm repeating myself over and over again. And there's a lot of syntax here. Okay, let's look at what the switch case would look like. It looks like this, right? So instead of doing if, else, if, I have another syntax. I use switch. So switch choice, where choice is whatever you're entering in, and then case. I check each case. And now it's more compact, and it's more readable too. I don't have that if, else, if, else, if, else, if. I have these break statements, and the break statements, what they do is they say, okay, do this, and then break. Do this, and then break. Do this, and then break. And that means I can do multiple statements before the break. It's not, I'm going to say this again, a separate scope. This is a scope from here to here, right? But these are not separate scopes. If you define something in here, because there's no curly braces, right, then it lives down here too. Okay? However, I'm going to give you an alternative to this. Use a scope anyway. Yeah. And I'm going to talk about this in a second. Okay, so break statements suck. Okay, and some languages hate break statements because break statements basically mean break out of this whole switch condition, right? Instead of doing if, else, if, I can use break. And once I hit one case that matches, break means break out of this line of execution. It kind of jumps from here to the bottom. That's what it does. That's what break does. And we're going to see break being used other places. Break is a special keyword that allows us to break out of that arm, that line of condition, right? That's what we're doing. It's going to break us out, okay? So this is what I want to do. And I could have multiple cases for the same arm. If I did case 1 and case 2, 1 or 2, and then I do the same thing, well, guess what? There's only one break. If I only have one break, if I forget one of these other breaks up here, let's say, for example, I forget this break, then 1 and 2 are the same thing. I do both. Break allows me to break out when I do a choice. If I don't have a break, I do both. Okay? All right, so why this then? Why am I doing this? Well, if I go back to this, could I not write this a different way, right? I could write this kind of thing in a different way, but I'm not doing if, else, if, else, if. This doesn't apply. I would not use a switch case here because I don't have multiple if, else, ifs. But down here, what I did earlier, when I did this, right, I could say that I could switch on character name. Here's how that would look, okay? Let's do that. So instead of doing this above, I could do something like this. Switch on character name, right? I could do that. Oops, character name. Right? And the switch statement would look like this. Case Tom, then do something. Case Bob, then do something else. Case Sarah, then do something else, right? And then there's also something else called the default case where I could do the other stuff. So this is a switch case statement, right? And it's much more compact in terms of syntax compared with if, else, if, else, if, else, if, else, if. Okay? But it's only useful when I have if, else, if as an option. If I have that in my mind, I'm thinking, is there a place to use switch case? Because my switch case might be a little bit more interesting. If I only have one if else, I wouldn't use a switch case. This is too much. It's overkill, right? If I have an if and else, right? If I have an if statement, I wouldn't do this. But if I have multiple choice, right, then I would do it like this, typically. All right? And many multiple choices. All right, so then let me complete this for you. So then if it's Tom, we could write this like this, right? But you're going to see some duplication, right? Just going to do that for a second. So this is what you're replacing, right? And here's this part. Some other name is entered. That's down here. And we'll just replace this with Bob and Sarah. So this takes the place of the other lines above. Look at all these lines here, right? All these lines here are replaced by this. So you might like this more, right? Again, there's nothing wrong with doing if, else, if, else, if that's what you want to do. If that speaks to you more as a programmer. However, I find that this is cleaner. There is a problem with this though, like I said, which is scope. If you want to create scope, see this one right here has a bunch of scopes. There's a scope here, and there's a scope here, and there's a scope here. These are all scopes. This only has one scope, all this. That's the scope it has. So if you wanted to create multiple scopes for this, you could do that by doing the following. You could do this. That is valid. This is also valid. You could do this too, right? Where the scope is its own standalone statement. In fact, here's something else. Try this. So nothing by itself and just a scope. That's also okay. Oh yeah. So I can do something like, age, int age is equal to 5, right? And that's its own scope, kind of thing too. You can do this by itself, with nothing, right? So scopes like this are totally fine, and I highly encourage you to do this even if you don't need to. Why? Control. It's extra But now you're going to say, wait, the syntax is almost the same now. Now, I mean, I didn't save much because else if I saved all those curly braces and now you're telling me that I need them again. Yes?
When you create a separate scope,
Yeah.
you still have to type break.
You still have to do break, yeah. Yeah, because what's going to happen is if you don't break, it's going to do the next one and the next one and the next one. It's going to fall through. It's called fall through, right? It will continue to fall through every case until it reaches a break. That's what switch cases do. It'll fall through all of them, right? So if I don't put this break here as an example, it's going to fall through the first case and go to the second case. And notice it even gives me an error. It says control cannot fall through from one case label, case Tom, to another. It doesn't like that, right? It doesn't like this. It needs to have a break. And I can do this too. I can put curly braces here too. I can say, here's curly braces. I'm going to give you the other way of doing it. You can do it like this. I was making the curly braces go first, and then I'm just going to move that up there. Right? Okay, and I'll copy paste that one.
Come on. Why doesn't it work?
Copy paste that one. And that's also an alternative. And I don't think it's bad, right?
Why doesn't it
I know it's a little bit more, this is more syntax, but what this does is it gives me more control. More scope, more control, right? And these things, these console write lines, you know, are contained inside this thing. It's containers. I want to put everything in jail, all right? Everything is in its own cell, put it that way, right? If I open the door, you know, without this curly braces, there's no cell. The creatures are out in the wild, you know, kind of thing.
Is
Yeah.
there a way in Visual Studio that we can like label certain parts of code?
Yes.
It gets really long
Yes.
and I get
Yes.
lost in it.
Yes, you can create regions, but we're not going to do that right now. Yes. The answer is yes.
Okay.
All right, so, yes.
Is there a way to set it up so you can type in like two different things, but they're still linked to the same case?
Yes. Yes. You can do that. Yeah. But for now, let's leave it alone because I want you to learn this first, right? Here's something else you can do. What about if I do cases and then I do if something in here, if, you know, agility is less than 4, you know, do something. I can do that too. I can do if nested inside of a case, right? And I can do a switch case, right? I can do a switch case inside of that too, right? Case 3, you know, break. Case 2. I can do it in different orders too. Doesn't make sense. I can do that though, right? I can do all this craziness. And I can take it further and I can do this too, even without anything. If my strength, right, is greater than 50, you know, or something like that, do something else too, right? I can do that. So I can do all kinds of nesting like this and it can become very complex and ugly, right? But I can do this if I want to. I'm showing you what's possible because you know what? Until we know that it's possible to do something, we don't know what we don't know. This you can do. You can do all kinds of crazy crap like this. Is it right? Not necessarily, because this is like convoluted. It's like, wait, what's going on there, right? So, but that is possible. Okay, I'm going to comment this out. That was just for you. So switch case. I want to talk about random number generation now really quickly. Okay? Random number generation. And I don't need this either, right? Random number generation is done with the random class. So the random class exists in the system namespace, okay? And because at the top, notice what we have system reflection, some weird thing here, right? We can also use the random class in here as well. All right, so I need to use system in order for me to use a random class. Yes.
I haven't done well, I have written down the cases, it's not the sub-cases.
That's okay. Don't worry about it. I'm just giving you examples, right? So you don't have to, write them all down. Like you don't have to do all this. So the random class is interesting. Now here's the question. Computers are like a set thing. Computers are like, they're very standard. They give you stuff. So how can computers be random? And the answer is there is no true random in computers. There's no true random. In fact, if anything, they have a table of numbers that they access, right? In a table, and then that table, those group of numbers is considered the seed. So I look at that seed, and I go through one at a time, and I pick from those numbers. It's pseudo-random. That's what they're called, pseudo-random numbers. So when I say I'm going to generate a random number, it feels like it's random, but it's not. Case in point, Minecraft. You know, when you have a random world and you have a seed, well, what that's doing is it looks at a table of the way it generates everything, and you can generate the exact same world by picking that seed. So there's no true random. You're picking from a group of values that exist in the system somewhere. So in your mind, when you think random, it's not really random. It's picking from a group of values somewhere else. However, for us, it's pretty good. It looks random to us, right? So the way you use random is first you need to declare it. Okay, so you can say random is the class, and we need to use the new keyword for this. So let's do that first. So we're going to do that up here. So I'm going to say I want to make a random number. Okay, here we go, between 1 and 10. So first I'm going to say random, and I'm going to make random is equal to new random. So what this does, it creates the random number generator. Okay, that's what I want you to think about it, all right? It's not really true. Well, it's actually the random object that gets created, okay? But for you, this syntax is what I want you to use. Random is equal to new random. Now, by the way, random can change, you can change this number to anything you want. This name. For example, I can call this random, you know, as an example, whatever I want, dice, right? Because dice is a random number, a random number generator. So random actually has a couple of overloads. I can go dice dot, and I can say next, and if I want to generate a value between 0 and 5, that's what this does. So next, if you look at it, if you hover over, it says next generates the minimum value, whatever I put in there, that's the minimum. And then the maximum value is the upper range that it does not include. It needs to be less than, we just talked about less than and greater than, it's less than the greater value, the number value. So if I do this, dice next, and I assign it somewhere, let's say if I console log it, console log, console write line, here it is. Right, I can do this. If I do something like this, and if I go 0 to 6, it's going to give me a value between 0 and 5. 6 is the boundary. It's going to go up to, but not include 6. It's the upper boundary. That's what it does for this little, that's how this function works. So let's run this thing and see what happens. So if I go in here and I go run it, okay, I say Tom, there it is. And I say, you know, agility is 35 and strength is 25. And then it's going to generate a number, and it's going to generate 0. Okay. Well, that's weird because it generates 0. What? By the way, at the top, notice it didn't include system. The using, I could explicitly say using system here. I could do that, and that's okay. You could do that, but it's implied. We always include system whether you enter it here or not. System is the namespace that's being included, so you don't need to do this. So down here, random, right? It's 0 to 6, and it gave me 0, right? Well, let's try it again. Let's see what happens. So if I run it again, the program, and if I say Tom and Julie 35 and I don't know, another value like 30, oh man, I got 0 again. Wait, what? How come I got 0 again? What happened, right? Well, it said 0, right, or positive integer. That's what I want to do. Random.next, right? So random.next I could use, but I want to use random 0 to 6, right? Here's something. Let's go back. Let's just do this, random 6. Yes?
I wrote what you did, and I got 2 random numbers.
Yay! You're awesome. Better than me, right? I got 0 twice. It is working, yeah. Let's try this again. So I had Tom, I got 0 twice. And I got Jilly 30, and this time 25, and I got 0 again. What the hell?
Is this just bad luck for you?
No. No. I'll tell you why, right? Because I'm going dice.next 6, which is what's happening, random or dice. I'm making a new random number every single time, right? this is running, over and over. Let's try this again. Let's try writing this console command multiple times. Like if I did this, right? Let's try this, see what happens, right?
You're gonna get like multiple numbers.
I should, but what happens is, in fact, do I? Let's see if what happens. 35 and 30, and I get a bunch of zeros and 522. Why? It's looking at the same table, right? That same table had 2 zeros, right, in there, and then I got 5, then I got 2 and 2. Okay? Now this is not really a die, right? Because I want to get dice between 1 and 6. If I roll a dice, like a 6-sided die, I want to get 1 and 6. How do I do that? Add 1 to it, right? So I can do something like dice next plus 1, right, would be a d6, right? So let's do that. So I can do this, dice, and let's just roll a d6 every time. There we go. Dice plus 1, and I'll even do it here to make it look the same. There we go. So this basically says 0 to 6, but not including 6, and add 1 to it, which means 0 becomes 1, and then 5 becomes 6, right? That's what happens.
It becomes 4.
Well, let's take a look. So if I run this again, and if I go Tom, and if I do 35 and 30, then I get this. Some random numbers. And if I did it again, I would get new numbers, right?
Can you do 1, 6, or do you have to?
Well, that's a good question. So you could do 1 to 6, but then it would be up to but not including 6, which means you'd have to do 1 to 7. Ugly, right? But it's also okay. You could do that. You could say this is also the same, 1 to 7, which means up to and not including 7. You could do that. That's the same result, by the way. But remember what I said? This is kind of a weird thing, right? A lot of times people are used to that, like next 6 plus 1, right? But this is start at 1, go up to 7, but don't include 7. So it's really 1 to 6, right? So if I did this, right, and if I was to run it again, then I put my name in, and if I said 35 and 29, then I get this, right? So here's a question for you. Random numbers, why am I showing you them right now? Because my friends, you guys are game developers, and without randomness in our game, we have no game. Honestly, right? Think about this. Once I have dice or some kind of random number generator, I can do all kinds of stuff with it, right? I'm giving you building blocks to make any game you want. Okay, a good example is any dice game, right? Any kind of random thing. I can choose random stuff from this, right? I can choose choice 1 or choice 3 or choice 2 or choice 6, right? Random. Why am I showing you this? Because here's your in-class exercise. ICE 3. I want you to initialize a Git repo. We did that already, yeah? And then I want you to declare initialized variables, name, primary attributes, secondary attributes, career variable, that's new, right? And the career variables are 2. I want you to declare career and has chosen career. Let's do that together. All right, so I'm going to get rid of all this crazy crap and do your in-class exercise 3 now, the part that I want to do. All right, this is just for you, for your learning, right? So, woo. Oh, I'm going to kill all this stuff. I'm going to kill all the way up to here. Okay? Back to here. This is all for you. This is like this stuff we tested so I can show you what it looks like. So here's what I want to do. I want to go up to the top. I have these. I don't need, I have min and max. Maybe I'll keep those. I don't need them, but I could definitely go in here and create some career variables in here. So secondary variables. And there's 2 career variables I want. Career variables. All right? And one of them is a string. That's a career. String career. And I also want another thing that is has chosen career, which is Boolean. So bool has chosen career. Please, this is your in-class exercise. Please follow along. Other things I want to do for now. I want to initialize my agility to 0, and everything else, I want to initialize these to 0, please. So please initialize all these variables to 0, okay? And same thing with awareness, toughness, and resolve. I definitely want to do those. I want to initialize everything to something. Even career, I want to initialize this to unknown. Okay? And I want to say has chosen career. I want to make that false. So I want to initialize everything to some value. Even character name is going to be unknown. Okay, so I'm going to do that too. There we go. So I've initialized everything, right? Let's push this up to GitHub, right? So I did this, and now I'm doing this.
There's a typo.
Where?
There's a typo there.
Unknown. Thank you. Sure. Let's push it to GitHub. So I'm going to say git add dot git commit -m, and I'll say declared and initialized variables. There we go. Okay? So that's this part. All done so far. I've done number 1 and number 2. Number 3. Here we go, right? Number 3, I want a prompt for a name. I did that already. That's right here, prompting for a name. And I want to present a menu of careers. All right? Army, Scion, Rogue, Telepath, and Tinker. All right? You can come up with your own careers if you want to. But here's what it would look like for a menu, right? So I'd say console.writeLine. Let's do this together. Select your career, right? Here we go. And then I'm going to say console.writeLine 1 Army, right? And I want to put this. Agility is 35, right? I want to say that strength, I'm making, kind of abbreviations. Yes, Damien. 35.
Okay, you might want to scroll back up a little bit. Please,
One sec. I'll do that in a second. Agility 35, strength 35, vigor 30, right? Perception is going to be 30. Int is going to be 25. And will is going to be 25. So that's your first choice. Army career, right? And we'll make a little bit of a brackets here like this, where we can say brackets, so we can say that the army choice is going to be all this.
So they're like preset stats?
Yes. That's what you're going to do. You're going to preset your stats. All right? And then I'm going to copy paste this line because there's a lot of lines, right? And I'm going to say something like this. So the next one is going to be Scion, right? Where the Scion will have maybe some other stats. You guys fix this up. You select your stats, right? So for the Scion's going to be a psionic user, right? In this crazy game. And maybe it's going to be like, I don't know, 30 agility, 35 strength. It's going to have 30 vigor. It's going to have 25, and it's going to have 35 here. How about that? That's going to be your Scion, all right? And then, next one. Instead of army, it's going to be, like it says here, rogue. All right, so rogue is going to be high agility, right? And we'll make this rogue. And high perception, but lower strength. So strength is 30, vigor is 30, perception is 35. There we go. That's the only change. Different stats, right? And we're going to copy this and put this next one. Number 4 is the Tinker. Oh, yeah. And the Tinker is going to have low agility, higher strength. Vigor can go to 25. And then the perception is going to go to 30, and the intellect is going to go to 35. As an example, and I think that's good. Did I do something the same? I did. No, they're all different. And the last one, let me see, did I do that? All 1, 2, 3, 4. Telepath. Yeah, telepath. Here we go. Telepath and then Tinker. Okay, so I'll do telepath first and then Tinker. So I'll copy paste. Telepath is going to be 4. All right, here's telepath. And so this will be like agility is 25. We'll say it'll be reversed. Strength will be 25. Vigor will be 30. And then we'll have 2 35s down here. Okay? And there's another one more. And this is the really cool one. I'm doing this for you to give you some points, right? But this is random. Random, baby, random. Okay, those are your choices for your menu. Okay? So your name, and then you enter a career. Okay? Does this make sense?
Yes.
Let's, and we just did this part. This part right here, right? So we're going to do a commit message, but first we're going to test it to see if it works. So it's going to look like this, Tom, right? And it looks like this, right? So what we want to do is we want to, it'll kind of display the menu, and then it'll give us a chance to enter the menu, right? So we want to enter the, kind of get the menu itself. So we're going to say something like career then is equal to console.readline, right, is what we want, because we're going to get a number, 1, 2, 3, 4, 5. But we want to get the number, and we want to make it a number, which means right now the career choice, if you will, or chosen career could be a variable, right? Could make this a chosen career. So they're only going to enter 1, 2, 3, 4, 5, 6. That's what they're going to enter, all right? So we want to be able to take the career and parse it, as an example, to do that comparison. Is it 1? Is it 2? Is it 3? And so on. So really, should career be a string, or should career be like a number, right? So let's make it a number. Let's make this, well, actually, we made it a string before. So maybe what I can do is I can have another variable called career choice or selection. Let's call that career selection. It's not in your requirements, but let's put that in. We'll say integer is career choice, right? And we'll say for now it's 0. There is no career choice, right? And if we say career choice is down here, we can say career choice then is equal to, right, a convert dot to int this thing, int 32, this thing here, right? That's my career choice. So I enter the career. It's going to say, hey, select your career. So if I did this, right, do a read line, right, then if I did it again and ran it, it would look like this, Tom. And then it's going to wait for me to enter my career. Like, for example, like 3, as an example, right? Does that make sense? So if I want 3 to be something, then we want to probably have, a console.write that says something like your selection, and then what this would be is you decide what you want to select. Career choice is where you're going to put it. So if I run this again, you're going to see that I'm going to say Tom, and then your selection is 3, as an example. So it's going to accept that selection. So that's the menu so far. All right, so we have. Let's put this up on GitHub. I'm going to say git commit -m, and we'll say added career selection menu, or something like that. Okay? I know we're running late. Bear with me. Remember, I've pushed this stuff. Whatever I'm doing, I'm pushing to GitHub. You can always get it from my GitHub. So even if you don't have everything, you will in a second, right? Okay. So now that I have this 1, 2, 3, 4, 5, 6 choices as an example, I'm going to go to the next part of my requirements, which are here. Using if, else if, set primary attributes in career variables. Compute secondary attributes, and if incorrect option is chosen, display an error message. Okay, so now this is more complex, but we've done this before, haven't we? We got this if, prompting stuff. So let's do 1. So prompting would be like prompt, right? Prompt for, are we prompting or are we setting? We're setting, right? So we're going to say if, right, the career choice, right, is equal to 1, then we're going to say that agility is equal to 35, strength, right, is equal to 35, vigor is equal to 30. Ow. Just got to do this one time. Perception is equal to 30, intellect is equal to 30, will is equal to 25, and sorry, did I do all of them? I think I did. 1, 2, 3, 4, 5, 6. Yes, I did. And I did this wrong. This should be 25 too. There we go. And my career is actually Army. So I can say career is equal to Army. Am I right? Choice 1, these are all the choices. Choice 1, these are all the choices, right? Now else if, here we go, here's the else if career choice 2, what do I want to say? Career is equal to Scion, right? And then I'm just going to copy paste this stuff because I'm just not going to type it all again. And we're just going to change the numbers so that it matches the Scion numbers, 30, 35, 30. So 30, 35, 30. And then it's going to be 30, 25, 35, 20. Like this. That's your Scion. And then else if career choice is number 3, then my career is equal to Rogue, right? And my agility is 30. And what is it? No, my agility is 35, 30. Let's just copy the same thing again. Okay, so do one of those, right? So agility is 35, 30, 30. So 35, 30, 30, 35, 25, 25. There we go. Almost done there. And I'm sorry I'm running overtime, but I have to do this for you guys so that we're all up to date. If you have to go, I'm going to put this up on career choice is equal to 4. It's trying to give me stuff that I don't want. Then career is equal to telepath, I believe. No. Is it telepath and tinker? I believe it is. Telepath and tinker. So this is telepath, right? Where my agility, all that stuff is this. That's pretty simple. It's just reversed. So it's 25, 25, 30, 30, 35, 35. And finally, I'll copy paste this whole thing this time. If choice is equal to 5, right, then my career is tinker, where I have, what is it again? 30, 35, 25. 30, 35, 25, right? 30, 35, 25, 30, 35, 25. Nice and easy. Not finished yet. I'm not finished yet, Damien. I'm still going.
Well, my computer is about to die.
Well, I don't know. Plug it in.
Where?
There's places you can plug in.
Is there?
Yeah, there's like plugs behind.
There's plugs behind and underneath. All right.
There's nowhere else to plug it.
Perhaps there's a plug. Here, come over here. You can come next to me. Here, plug over here. Okay, no problem. Just plug in right here. There we go. So then now that you have all this, you have all these choices, right? That gave me all these choices. Random is for you to do, right? If you choose for now, let's just use this. Instead of random, you're going to do the random one. We're just going to use else, and we're going to say something like console.writeLine. You entered an incorrect choice, right? Please run the program again, right? Because we don't have a choice right now for 6. You're going to make 6. You're going to make number 6, okay? So else is going to be there, but 6 doesn't compute. I put the 6 in there for your random, but really only 1 to 5 is going to work, okay? And it kind of sets these things up, okay? Sets those options up. So I've got all these options, right? And I got them all, and I made an error message. So let's put this up on GitHub. Let's try this out. If I try it, and if I say Tom, and if I type in 2, then it's going to calculate those things. I don't know what it did. I can't prove that it's done yet because I haven't done the output yet, but I did this, okay? And then I'll put this up on GitHub. I'm going to say git add dot git commit minus m, and we'll say set attributes and career according to career selection. Right? That's what we did. Now, there's one thing we didn't do. If we've already calculated these, right, and if we made a proper choice, then we can calculate our secondary attributes, right? But if we made an incorrect choice, if a choice hasn't been entered, then it's bad. So here, right, we have another variable that we can use because has chosen career is false, right? So we're going to say that has chosen career is true every single time. We can say that, you know what, if we come here, made it here, has chosen career is true, right? Because we chose something that's real, right? By the way, there's other ways of doing this. So we can put that there, and that there, and that there, and that there. But if we come to this point, has chosen career is false, which means I can test for that, right? I can test for that. This is this variable, right? So I can, after all of this, I can sit there and say, if has chosen career, if that's true, let's make it explicit like this, just to make it so that's very clear. Then, what do I want to do? So awareness is equal to, remember what it's equal to? Agility plus perception, right? And then toughness is equal to strength plus vigor, right? And then we're going to say resolve is equal to intellect plus will. Now I did this because we don't want to set these if somehow the person went here, because then it'd be all zeros, right? Because he didn't enter a proper choice. So we need to do this thing. This has chosen career. This is when I want to do that stuff. And I don't even want to print out my character sheet unless I have a proper career chosen. But if I have a proper career chosen, this is where I can show my character sheet. So I can say something like, so this is where I can say something like compute secondary attributes. And this down here is where I can output the character sheet. Okay? Output the character sheet in here. Don't worry, I'm going to put this up on GitHub. You're going to have my code in 1 second, a few minutes actually. Sorry, I know I'm running 5 minutes late. Bear with me, okay? I don't want to run late, but I want to do this, right? That's my next step. So I have ensure a chosen career is true. Good. Then clear the console, change foreground and background colors, set the title bar. I did all that earlier. So that means that I did this up here, but I want to do clear the console again, okay? So clear the console, that's going to be way down here, right? Because I've entered everything, I want to clear everything and then show my character sheet. So then how am I going to do that? Well, I want to do a console.writeLine, and I want to do some of these, right? To make it nice, like I said before. This is what you guys did last day, right? And then I want to do a console writeLine, and we'll say character name, and we're going to inject character name. This is the bare minimum, but I need a $sign up here. Sorry, I did the wrong way. I meant to do this. I'll be okay. Right? That's the character name. So I did that first. Yeah, there we are. And then once I've done that, then I want to separate it by this. Right? So I want to kind of say this is the character name. And I also want to do the same thing with career. So I'm going to copy these 3 lines. Right? Because I want to speed through. I don't need this one. And we'll say this is the career. Right? And the career is going to be career. I'm going to type that in there. Right? So that's the career. If I want them to be aligned, then I can do one of these where I can kind of align them the same so they look a little nicer. Right? And now we can do our attributes. I'm going to grab these 2 lines. Right? And it's going to do one of these. Instead of career with this, I don't need this. I can just say attributes, so primary attributes. And then I can grab these two lines again, actually just this line, and put this in there, and we'll say this is agility. You know where I'm going with this, right? Really quickly, and then I can just copy in the rest. Strength, vigor, perception, intellect, and will, right?
I decided to assort them just based on, just to make them a bit.
You know you're on camera, right?
Oh. Whoops.
Shh. You can power my next to me, my son, but not all the other stuff. Thank you very much. All right, so there we go here, and here, and here, and here, and here. And we can align these because it looks like that needs to be pulled back here, and this can go there, and that can go there, and so that we have a nice alignment of stuff. Then I can grab one of these and go here. Oops, almost done, I swear. Ah. And I'll grab these two, and this will be secondary attributes. I know, right? And then here, I'm going to grab these three lines here, and I'm going to go here, pop them in there, and this will be awareness, toughness, and resolve. So essentially, I'm showing you what I would have done last week in your in-class exercise 2 by doing in-class exercise 3 like so. All right, and then finally we'll end it off like this. And just to make it even more interesting, we'll do a console.writeLine, press any key to continue, where we do a console.read key, true. Phew. Speed run, right? So how does this look? Let's test it first before we put it up on GitHub, and then you'll have everything in a second. Let's run this thing. And if we do that, we say Tom, right? And I choose Army, and then boom, Army, Tom, blah, 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 right? Isn't that beautiful? Yes, my friends, it's a true beautiful thing, right? This is where I want you, yeah, this is where I want you to start, all right? So I'm going to put this up on GitHub. I'm going to say git add dot, git commit -m, and we'll say added simple character sheet output. Git push. Here you go. Once I do this, you have access to my repository, which is this. Wait. See all this? If you go to the top here, this is my repository. This is where it is. All that stuff I just did. You have all of it, right? Now your job is to do number 5 and 6, which is these two parts. So I want you to refactor your if-else and convert it into a switch case. Yeah, baby. This is your first time you're doing something completely on your own. And then number 2 is I want you to use random career option where you randomize those numbers. Remember that you could definitely do, I want you to do 5d10, so 5 tens, right? Some people might say, what if I did like 5 to 51? Is that right? And the answer is no, because that is equal chances to get 5 or 51, which is not the case when you roll dice. You have a bell curve. You're on camera. And then what happens is, right, if you roll 5 dice 5 times, you want to do like my random, my d10, you know, from 1 to 11, a bunch of times, 1, 2, 3, 4, 5. 1 to 11, 1, 2, 3, 4, 5. And keep doing that for each stat. That's what you're going to do. And once you've got those stats randomized, awareness, toughness, and resolve are the same. Question?
Yeah, sorry. When we're working at home, do you want us to see, or do you want to see all of the pushes that you made throughout the redo stuff too, or can we just copy straight from yours and start from there?
I would start from there.
Okay.
Your stuff is going to be, well, actually, what you should be doing is working with me right here, and then you should be done, right? But I understand if you haven't done it, because I went too fast at the end. So yeah, so take a look at my repo and then add your own stuff, okay? But at least you should have some, because we did some together, right? Okay? Yes.
I'm not seeing the repo.
Try again. It's there, right? Take a look. It's here. This is the repo. Oh, wait. I made it private. Haha. Right, let's do that. Let's make it public. Thank you for that. Public. Oh. Okay, and that's it for today, guys. Thank you so much. You guys can go, but hopefully you got everything that you need.
Thank you.
Now it's public. You should be able to see it. Okay, and I'll stop recording now.